Good evening all, and welcome to another episode of the Kontakt Script Programmer. Today we're going to be looking at 3.7, which is the exclamation mark, which is a string array. So in the last installment of this series, we were looking at the string variable. It should make pretty good sense that it moves straight into string arrays, although there is an interesting little syntax here. I am having a little bit of trouble with the Kontakt comments, or the YouTube comments, sorry. So if I'm not replying to your YouTube comment, it's because I can't. So maybe shoot me another comment and maybe it will start to come through. I've got a couple of really great comments so far wanting to talk about specific features of Kontakt, and I haven't been able to actually reply to them because I'm still kind of getting used to some of the new YouTube formatting. I think it might be my browser. So if you are trying to contact me, please let me know. Just shoot me another message. I'm not ignoring anyone. So today we're going to start with 3.7, the string array. So we declare a string array by hitting the exclamation point and then we call it a name. Okay, and then we define in square brackets, just like we do with most of our array, or with all of our arrays, the number of elements required. Okay. So the maximum size of arrays is 1,000,000, and we also can't declare them the same way as we do string arrays. We can't declare them in the declaration, so we can't declare this note and then give what the string is inside the square brackets or anything like that here. And string arrays can't be made persistent, so if you're looking at something that is going to hold over across multiple instances or snapshots, you probably want to look into using just string variables instead of string arrays because they won't work properly. So this patch here is going to give us the note that we're playing. You can imagine how maybe through a bunch of nested if statements we could turn this into a chord recognition device, which is actually how most chord recognition devices are built inside most doors. So very, very handy to have one. There's lots of error checking and stuff involved, and we're only going to breach the subject a little bit today. So on initialization, we declare a count variable. This is something you're going to see a lot in programming. While counting loops are a great way to iterate over a number of values or inside an array and draw out values without having to write every single check. Okay, so that's what the count variable is going to do for us today. The declare, we're moving on to one of the string arrays that we're talking about. And its string array has 12 elements, or this string array has 12 elements. And inside each of those elements is a string. Okay, they don't have to be one letter, they don't have to be 2 letters, they don't have to be 12 letters. They can be whatever you like. Within reason. I'm sure that there are upper limits in terms of characters, but they can all be different lengths is what I'm trying to say. So we can use these for totally different things. In our instance today, we're going to be using them to build this note recognition device, but we don't actually have to use them this way. We can use them for many, many things. So we declare our note. It's got 12 elements in the array. That's because we've got 12 tones in the musical system, or in the Western music system. We could declare more if we were looking into quarter tones and things like that, although I suppose you'd have to have a quarter note keyboard or something cool like that. So on each of the elements, we're picking the position. So we're saying in the first position, or element 0, we're going to call it C. Second position, or element 1, D flat. 2, D, 3, E flat. The reason we're actually calling these flats and not sharps, in case you're used to saying maybe sort of C, C sharp, D, E flat, E, F, F sharp. If you're used to saying that, it's just a passing thing. You can actually use that if you wanted to. It's generally flats being used in sampling more so than sharps, just for formatting and for intro into some DAW. So some DAW don't read the pound or the sharp sign. Some won't read that. So we don't want to run into any formatting errors. So we're going to stick to the convention, and throughout all the courses and everything I'm going to show you, we are going to stick to the convention of using flats instead of using sharps. So we go down our list, or rather up our list, and bring in each of our numbers. Okay, it is kind of important that they're in the order of, you know, lowest to highest. Otherwise, you would have to jump around just to show how it would work. And the algorithm we're going to work with today, which is further down here, will give you it in steps. Okay, so from there we declare another string array, okay, called name, and that one's going to have 128 elements in it. Okay, so then we're going to throw open our while loop here, and this is going to say count, which is this count variable up here, okay, which will start at 0. While it's less than 128, going from 0 to 127, so there's our max values, we're going to pull up the name, so this is this one here, okay, then we're going to drop in the variable count inside, and we're going to read the very first element of name. Okay. The reason we're going to do this is so that later on, when we print out this message, we're going to say note played name and then the event note. Okay. So we're going to drop in note, which is this big array tree here. And we're going to do this function called count mod 12. Now, if you're not sure what mod means, mod is short for modulo, which is in mathematics terms, it's dividing something, and then instead of taking the divisor, we're taking the remainder. Okay, so if we divide, say, 13 by 12, we would get 1 and 1 left over. So this value would be 1. Okay, because it's mod 12. Okay, so we're going to take whatever the count is, okay, pop it in here, mod 12, and that's going to become the position that we're going to read, which is going to give us each of these results. Okay, so if we were to take, if we played a note on our keyboard, so if we played, say, the C sharp or the D flat, we would get a 1, okay, which means we would throw it in here, we would get mod, and we would come out with 1. Okay, sorry, so if I use D flat as an example, it might be 13. We're going to do 13 mod 12, which is going to give us 1, so it's going to say D flat when it comes out later. Okay, from there, we are also using this count divided by 12 take 2, and this is to make sure that it works over octaves. Okay, so knowing that it needs to go all of the octaves, otherwise we would only get 1 octave worth. We need to combine these two equations together. After that, we increment the count value, okay, and then the count value continues again, okay, and it's going to go until it's 128, and we'll keep going every time we play an event, because it's going to run name down here every time we play something. Okay, so when we play a note, we're going to run it through here. We're going to get the modulo. We're going to check the octave that it's in. We're going to increment the count to make sure that we've covered everything, and then we're going to print the result whenever we hit the note. Okay, I know that might sound a little bit confusing, and hopefully I explained it kind of well. It's going to make a lot of sense once we put this stuff together. These kind of modulo equations and different mathematical equations are pretty low-level stuff, but you're going to use them time and time again, particularly things like this while loop. It's a very, very similar method to, say, like C++, where you'd have like while I is less than 127, I equals whatever, I++. So adding in exactly the same thing, really, really popular in programming, saves us from having to write this equation many, many times. Okay, so let's move up and take a look at building this. There are a few brackets in this and different states, but again, it's going to be one of those ones that's very, very handy for us to write out ourselves. Okay, so each one of these we'll have to write out. We could go through and you can copy and paste if you really don't want to write this stuff out. It's really up to you. I'm just going to do it just for the sake of practice and fun. We've got each of these declared notes. Okay. Now the only bit we didn't declare was the count. So don't forget to do that. So now we've declared a counter. Let's go down to the bottom. And just give myself a little bit more space. Okay, from there we're going to declare the name array with 128 spots. Inside there we're going to, well, it's not really a loop actually, but we're going to bring open this counter. Okay, and then we're going to go name, the current count position, and that's going to be iterated over multiple times, as is this. Okay, count mod 12. Remember that's in square brackets, not round brackets. From there, we're going to count over 12, take 2, and then we're going to increment our count variable so that it runs through all 127 values. And on note. Then we're going to go message, note played. So that, again, we could even do that as a string if we really wanted to, not times, don't forget about that. And name and the event note. Okay, so the note that we're going to get is going to get dropped into the name. We're going to check it with the counter. We're going to mod it. We're going to check the octave. We're going to print it out with a counter. Okay. So let's have a quick look, see if that works. There we go, note played, G2, D2, C3, F3. So if I remove this element, let's just take a really quick look. It also works. We actually just use, instead of modulo 12, maybe we could use count, we'll use the second part of the equation. See what happens there. So that's going to, yeah, so there we go. So that gives us just the modulo number, and it's a bit dodgy, but that's, so what that's giving us is that's giving us the octave that we're in, okay? Because as I jump down, you'll see all of these are in 2, all of these are in 3. I'm just doing this with my MIDI keyboard. I could do it up here as well. See how all these are in 3, all those are in 4, all those are in 5. Okay, so when we put these together, we're getting which note we're playing, not just that we're playing a G, but which G we are playing. So we get E4, D4, B3, C4, etc. So it is pretty handy to have it this way so that we have the most amount of information on each of the notes, especially if we were to look at key switching or different articulations, we could program them this way. Kontakt also has its own little some other settings inside the group editor that we could use, but we're going to use this method pretty commonly because it gives us so much detail. Okay, so we could use this half of the equation if we wanted to work out what octave we were in, okay? And we could use this half of the equation if we wanted to work out what note we were playing, and together we can work out what note in what octave, okay? So thanks for checking out the Kontakt Script Programmer today. I hope 3.7 was useful to you. We will be back again soon with 3.8. Thanks.